Welcome back to The Explainer. Today we're diving headfirst into the fascinating, slightly terrifying, and incredibly complex world of figs. If you've been thinking of fig as just, a simple, sweet little treat, well, you're in for a pretty wild ride.
Let's kick things off with a viral internet claim that's been absolutely freaking people out lately. It states that at least one of the figs you've eaten in your life probably had a dead female wasp inside of it. And the really wild part? The claim says this happens because a female wasp literally burrows into the fig, gets trapped, starves to death, but somehow manages to bring pollen with her. It's a bold, kind of horrifying statement, right? And it is exactly where our mystery begins today.
So I just gotta ask you directly, when you bite into a delicious, jammy fig, or maybe a dried one with that signature crunch, are you actually crunching on dead wasps? It is the number one question everyone asks the second they hear these rumors. But before we answer that definitively, we really need to understand the mind-blowing biological science of what a fig actually is.
Okay, so here's the core misunderstanding about figs. They aren't actually fruits at all. At least not in the traditional sense. They're inside-out flowers. Basically, a fig starts off as this fleshy stem that traps hundreds of teeny tiny flowers inside it. When those hidden flowers are pollinated, they produce the real fruits. Each tiny tadpole-like structure inside the fig is an individual fruit with its very own seed. And here's some immediate relief for you. That signature crunch you feel when eating a fig, yeah, that comes from those individual seeds, not insect legs. But wait, if the flowers are totally trapped inside, how on earth do they get pollinated? I mean, bees definitely can't get in there.
Well, it all comes down to one of nature's most highly specialized and honestly brutal life cycles. Meet the fig wasp, specifically Blestophaga piscens. This little insect is smaller than a gnat and is perfectly evolved to fit through a microscopic pinhole at the bottom of the fig called the eye. Here's how this intense relationship plays out. The wasps lay their eggs in inedible male figs, which are called capri figs. The wingless male wasps hatch first, and they immediately impregnate their own sisters while the sisters are still inside their eggs. Then, the males spend the rest of their very short lives boring an escape hole out of the fig, and they die. When the pregnant females finally hatch, they crawl out through that hole, rubbing against male flowers and getting totally coated in pollen. They fly off to find a new capri fig to lay their eggs in, but often they get tricked into entering a female fig instead. As she squeezes through the super tight eye of the female fig, her wings get completely ripped off. She pollinates the flowers inside, but she physically can't lay her eggs. Trapped and wingless, she dies inside the fig. So yes, the wasp dies inside. But hey, before you swear off figs forever, take a deep breath. Thanks to a process called Parthenocarpy, you are almost certainly not eating wasps. Parthenocarpy is basically the development of fruit without any prior fertilization. Almost all the fig varieties grown commercially here in the United States, think Black Mission, Brown Turkey, Cadota, or your common Ficus carica, they're totally self-fertile. They don't need wasps to bring in pollen at all. Plus, in many parts of the U.S., like Zone 6, the climate is just way too cold to even support the fig wasp's life cycle anyway. Now, you're probably wondering, what about the few varieties that do need the wasp, like the Calamirna fig, which is famously used for dried figs, and those fig cookie fillings we all know? Well, even then, I promise you aren't crunching on bugs. Figs actually contain a really powerful protein-digesting enzyme called ficin. This enzyme completely breaks down and dissolves the tiny wasp carcass. It basically turns the insect into a microscopic pinch of liquid protein that just gets absorbed by the ripening fig. Nature literally leaves no trace behind. All right, now that we've cleared up all that wasp anxiety, let's pivot to the true heroes of this explainer. 300. That is the exact number of self-fertile, entirely organic fig trees cultivated by a guy named Brent Morgan at Hillgeert Farm in Pennsylvania. Brent is basically what you'd call a fig wizard, and the sheer scale and dedication of his one-man operation is just staggering. What really makes Brent's 300-tree orchard so incredibly unique is that he focuses entirely on fresh figs. See, over 90% of the figs farmed in the United States are grown for the dried fruit market, not fresh. But fresh, perfectly ripe figs have this incredible jammy texture, and they're just packed with fiber, calcium, and potassium. Yet, because the industry is so heavily skewed towards dried products, millions of people have literally never even tasted a fresh fig. And get this, Brent is pulling off this massive fresh harvest in Zone 6 in Pennsylvania. This is a remarkably hostile climate for a plant that is native to the hot, dry regions of the Mediterranean and the Middle East. It's exactly why the American fig industry is largely concentrated in sunny California. But in Pennsylvania, Brent has to battle incredibly humid, wet summers and brutally bitter winters.
In fact, it gets so incredibly cold that fig trees there will regularly die all the way back to their roots during the winter. Because there is almost zero agricultural research on growing fresh figs in this kind of climate, Brent has had to figure out literally everything through a decade of relentless trial and error. So how do you actually build an orchard like this from scratch? Well, you can't just plant fig seeds because seeds don't guarantee the new tree will have the same traits as the parent. To get consistent, high-quality varieties, you have to completely master propagation from cuttings, and it is an exacting science. During the dormant season, you cut 30-centimeter branches. You absolutely must sanitize your tools with alcohol to prevent bacteria from entering the open cuts. Then, those cuttings are wrapped in wet newspaper, placed in plastic bags, and refrigerated for months. When it's finally time to plant, you wash them thoroughly to remove any mold, trim the ends, completely remove the lower leafi, and scratch the base to help it absorb moisture. Finally, they're planted into a sterile medium like cocoa peat. Sometimes he even uses custom setups, like a zipper pack punctured with an awl to get the perfect drainage. It's literally laboratory-level agricultural science applied right there in the dirt. Once those young trees are actually established in the orchard, Brent has to protect them from those lethal Pennsylvania winters. Remember, the freezing cold will kill the tops of the trees outright. So Brent devised this extreme winter defense system. First, he cuts the trees back to just 1 or 2 nodes above the ground. Then he uses string to literally fold and anchor the remaining branches right down into the dirt. He packs bags of leaves around them for insulation, covers the whole shebang in soft synthetic roll covers, and then applies heavy mulching on top. And he does this for all 300 trees completely by hand every single fall. But of course, the labor doesn't stop just because the snow melts. Springtime in a rainy, humid climate brings a whole new set of challenges. Brent has to do incredibly labor-intensive spring pruning across the entire orchard. Why? Because if the leaf canopy gets too dense, it blocks out the sun, which severely slows down fruit ripening. And even worse, poor air circulation in a humid environment leads directly to fungal rot on both the leaves and the fruit. So Brent carefully goes through, completely removing any growths at the base that haven't set fruit, just ensuring maximum light and airflow for all the healthy branches. Now, all that pruning brings up a really surprising and quite painful occupational hazard of working so closely with these trees. When you're pruning or harvesting, you have to watch out for fig latex. It's this milky white substance found in the branches, the leaves, and the stems of unripe figs. If this latex gets on your skin and is exposed to sunlight, it will literally cause chemical burns. That's exactly why commercial harvesters out in California usually have to wear long sleeves and heavy gloves. All of this intense hands-on labor results in a massive difference in how these figs actually make it to your table. Brent harvests his fresh figs by hand every other day. He picks them at absolute peak ripeness. They are lusciously soft, sometimes with beautiful shallow cracks down the side. And by the way, that's actually a sign of perfection, not a defect. He has to pick them quickly too, otherwise they become overripe, sugary neon signs for ants, yellow jackets, and fruit flies. Now compare that to the commercial dried fig harvest, which makes up over 90% of the industry. Those figs are left on the tree until they literally fall off onto the ground, or farmers bring in massive fans to blow them off. These super ripe, oozing figs just lay there in the dirt. Eventually, they get mechanically swept up, and because they've been sitting in the dirt attracting all kinds of critters, they have to be fumigated. They're literally sprayed with gaseous pesticides to kill whatever crawled inside them before they are washed and processed. So the big takeaway here is this. The fig is an absolute marvel of both natural biology and human dedication. From the tragic, highly specialized life cycle of that tiny wasp, to the flesh-dissolving enzymes, right down to the extraordinary, labor-intensive wizardry of farmers like Brent Morgan who battle the elements to bring you perfect, organic, fresh fruit. It's a complex, beautiful, and slightly messy story. So I leave you with this final thought. Next time you bite into a sweet, jammy fig, are you going to be thinking about the wasp or the wizardry that brought it to your hands?
Ready to grow? Master the science of Scribe now.